Imagine taking a deep breath and noticing a faint sweet smell in the air, something famously associated with bitter almonds. In classic mystery novels, that scent often signals only one thing: cyanide poisoning. From Agatha Christie paperbacks to Cold War spy stories, cyanide has earned a reputation as the undisputed king of poisons, the ultimate invisible assassin. But beyond Hollywood thrillers and true crime podcasts, what exactly is this terrifying substance? How does it work so fast? And would it surprise you to know that cyanide-related compounds may be closer to everyday life than most people realize? Welcome back to Basic Things. Today we are pushing past the myths to uncover the fascinating truth behind the world's most infamous poison. To understand why cyanide is so feared, we have to look at what it actually does to the human body. At its core, cyanide is a simple molecule, one carbon atom tightly bonded to one nitrogen atom. Yet this tiny structure can interfere with one of the body's most essential processes. When cyanide enters the body, it acts with alarming speed. It does not stop the lungs from breathing. Instead, it prevents the body's cells from using oxygen properly. It affects the mitochondria, often called the powerhouses of the cells, and blocks a key process involved in producing energy. Your lungs may be full of fresh air, and your blood may be carrying oxygen, but your cells can no longer use that oxygen effectively. In a sense, they suffocate from within. That rapid internal shutdown is one reason cyanide has appeared in stories of assassinations, espionage, and warfare throughout history. But here is where the story takes a surprising turn. Cyanide was not simply invented in some villain's laboratory. It is also a naturally occurring substance and part of one of nature's oldest defense systems. Plants have used cyanide-producing compounds for millions of years to protect themselves from insects and hungry animals. The seeds of apples and the pits of cherries, peaches, and apricots contain a compound called amygdalin. When crushed and digested, amygdalin can break down and release small amounts of hydrogen cyanide. But there is no need to panic. Ordinary fruit consumption is not the same as poisoning, and the tiny amounts people naturally encounter are usually handled by the body. Cyanide-producing compounds are also found in foods such as lima beans and cassava, a starchy root vegetable eaten by millions of people around the world. When cassava is prepared properly, it can be safely consumed. Nature, it turns out, invented chemical defense long before humans did. So cyanide is both a natural plant defense and a dangerous poison. But surprisingly, it is also an important part of modern industry. It is not only associated with destruction, it also plays a role in creating materials and products used around the world. In the early 18th century, cyanide chemistry accidentally contributed to the discovery of Prussian blue, the first modern synthetic pigment used by famous painters. Today, cyanide compounds are produced globally for carefully controlled industrial processes. In mining, cyanide is used to help extract precious metals from ore. Cyanide compounds also play roles in producing certain plastics, synthetic fibers, paper chemicals, and other industrial materials. Cyanide chemistry is even involved in the development of some pharmaceuticals. Cyanide is the ultimate chemical paradox, a simple molecule made of carbon and nitrogen, a scent famously associated with bitter almonds, a deadly spy weapon, a plant's natural armor, and an industrial workhorse. It proves that in chemistry, substances are not simply good or evil. Their meaning depends on their form, their dose, their setting, and how they are used in the world around us. Thank you for watching this episode of Basic Things. If you enjoyed this dive into the dark and surprising world of chemistry, please hit the like button, share this video with a fellow history buff, and subscribe to the channel for more fascinating stories behind the simple things in our world. Until next time, stay curious.